Hello and welcome to Mr. Connally's Math. We've got lesson 8.1.2 today, problems 823 to 828. Don't forget to like this video and subscribe to the channel to get information about future videos. Guidelines for using this video effectively are: watch and listen to the video. Sound should be on. Do not skip ahead. Do not just mindlessly copy the work. Pause the video when you need time to write or think. Put a question mark next to the problem you don't understand. Rewatch and listen to the video when needed, or ask questions in class or in the comments below. All right, 823. The two histograms below show how precisely Lou threw 50 darts with his right hand and then 50 with his left hand. Study the two histograms. Okay, if you never played darts before, they have these little, almost look like little pencils on the end, and they have little feathers, and you throw them against the wall, and you're supposed to hit a target called a bullseye. It's a bunch of concentric circles, with the middle circle being the most important. Okay, so the closer you get to the bullseye, the better you do. This person, apparently Lou, can throw with his right hand and his left hand. Okay, so you can imagine if you were to throw with your right and left hand, would they be the same? Would one be better than the other? Which one would? Let's think about that. Okay, so estimate what box plot would look like and make a parallel box plot. Okay, so remember, a parallel box plot is two box plots on top of each other using the same number line. So let's use this number line at the bottom, the same as this one. They use 0, 3, 6, 9, 12. We'll do the same thing on ours, 0, 3, 6, 9, 12. Notice I'm using the boxes in your grid paper or your graph paper. So 1, 2, 3, 4, 5, 6. You should have about 6 squares there, and make it about 3 squares high. We want to put our box plots on these two lines right here, one for right-handed and one for left-handed. Okay, so for instance, the right-handed one, let's look at these numbers. Let's think. This is saying right here that this is the lowest number. It could be anywhere between 0 and 3. So let's assume that it is 0. We're just guessing, so it doesn't need to be 100% accurate. Let's put that line there, that vertical line, for the minimum on the right hand. And then 18 looks like the highest over here, so let's go all the way to the end, and that's 18. Okay, so you kind of get the idea. We're going to make a box plot somewhere in there like that. Okay, now let's look at the middle of the data to kind of guess where our median is. So we see the data kind of goes up like this. It's got a little gap here. It looks like the middle of the data would probably be possibly a median or even a mean, because this is almost a normal curve. So maybe somewhere around 9 might be the middle of the data. Does that look like about the middle of the numbers? Okay, so that would be somewhere around here. Now you need to figure out quartiles. So what would be a quarter? You know, maybe somewhere around there and somewhere around there, where those lines are. Put a number for those and then use that to make your box and finish the right-handed box on top. Let's look at the left hand though. The left hand starts at 0, so we'll put our line here, and ends at about not 18 but 15. So that'll be the end of our line. Let's go ahead and draw that right there. Okay, so now the same reason, same idea, we're going to put a box somewhere in there like that. Okay, so look for the middle of the data. This data seems to be sloping down. It's skewed right. So let's think. Where would the middle of this be? Okay, so this one looks like the middle would be, most of the data is going this way. It's more on this side of the curve. So maybe it's not in the exact middle. Maybe it's more off to the side like this. Maybe that's probably where the middle is. So come up with a number for that, and then use that as your median, and then break that information up into quartiles like that. And then use those numbers that they correspond to for your first and third quartile. Okay, so go ahead and draw those boxes in there, and let's look at the comparison of the two to see if we can find more information about this. All right, let's look at B. Now let's compare the center and spread of these data. Okay, so let's start with the right hand. Let's talk about, it wants us to compare center, shape, spread, and outliers. Okay, so we've got it over here. We'll talk about center in the first sentence, then shape, then spread, and outliers. Are there or are there not? You'll have to decide. Okay, so decide which is closest to the middle, the median or the mean. And the shape, what is the shape of this? Is it double peak? Is it single peaked? Okay, is it skewed? Is it symmetrical? Or is it uniform? Look those up from your notes and decide on what it is. Pick two of them to describe this data. And then the IQR, that's how about how far apart the box is, the first quartile to the third quartile. So go ahead and enter an estimate for that based on your graph from the previous question. And then decide, based on the IQR, does it have high variability because it's a large number, or if it's a small number, it should have low variability. Okay, and decide if there's outliers for that one. Look at this number. Is there anything that stands out? Is there a big gap anywhere? Okay, between numbers, decide there. And now let's do the same thing with the left hand. Is it the mean or median closest? Is it double peaked, single peaked, skewed, symmetrical, uniform? Pick two of those. That describes this one. This one's a little different than the right-handed one. And then, let's see. And the last one, are there any outlier or IQR? So count the length of the box from the previous A question, and then write down about outliers for the last one. Okay, pause if you need more time. All done? Writing it down? Great job. Let's look at the data now again. So let's see. Is Lou more precise throwing with his right hand or his left hand? So real quickly, looking back at the data, let's see. It appears that most of the information is to the left. That means it's 0 inches from the bullseye. So that means that if you're looking at the bullseye, that means all of the data is close to the center. Okay, so in order to win the game, you're trying to get as many bullseyes as possible. So the closer you are, the more points you get. Okay, so if most of the data is to the left, meaning it's closer to 0, that means it would be closer with his left hand. With his right hand, it seems to be that there's a lot of numbers that are kind of far away from 0, as much as 18 inches away. Okay, so it seems like his right hand is, the darts are farther away from the circle as opposed to close to the circle with the left hand. So which hand does that make him better with? Okay. Go ahead and write that down. Lou is more precise with which hand? And explain why you chose that hand. Okay, now for D, let's use the box plot and think how many IQRs above the median Lou's better hand is. So look at this one, decide which is his better hand, and it says how many IQRs above the median. Explain your thinking. So Lou's better hand is blank IQRs above the median. Okay, so if we've got our drawings here, something like this of his right hand, and then something like that with his left hand. So how many IQRs above the median his better hand is? Okay, so you look at the boxes, the IQRs, and how many above the median his better hand is. So look at that and decide how many of those little boxes above it do you think it is. Okay, enter your answer in there. And then explain why you thought that. Pause if you need more time. Okay, let's go on to the next. 24. Find the missing lengths or values on the diagram below. Assume that the line is evenly divided. All right, so it looks like we start at 0 here and 0%. And on the top it's 1.0 and 100% on the bottom. Okay, so let's count these gaps here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there's 10 gaps there, 10 intervals. So that means we've got to take 1.0 and divide it by 10. So what's 1 divided by 10? That's 1/10. So that means each one of those gaps is 0.1 or 1/10. Okay, so let's go ahead and label that. This would be 0.1, 0.2, 0.3, 0.4, 0.5, etc. And 0.9 and 0.10. There's no 0.10. It would be 1.0. Okay. Now, that means if there's 10 intervals, we've got percents. That means we're talking about 10%, 20%, 30%, 40%, 50%, 60, 70. You can write 80%. You know, fill those all in if you like. It might be helpful to you. Okay, and then, all right, now it wants to know how long each interval is. So you need to find A. How far is it from 0 to 3.0? So it would be 3.0 minus 0. And for B, you'll do the same thing. It's right over here. That goes from 0.6 all the way to 1.0. Okay, so do some math there. You probably subtract the higher number from the smaller. And then C is over here. How far is it from 60 to 100? Give that answer in a percent. And D, same thing. Find each portion of this one. There's 2 for D. Do you do anything special? No. It's just trying to have you think about it a little bit. And that'll be a percent as well. Okay, so go ahead and do the work for that one. Pause if you need more time. All right, let's move on to the next. 25. Joaquin has agreed to lend his younger brother $45 so that he can buy a new tank for his pet lizard. Joaquin, let's go ahead and circle that, is charging his brother 2% simple interest. Oh, what a nice brother. Per month. Okay, so the time period is per month. If his brother pays him back in 6 months, how much will Joaquin get back? Okay, so we're looking at not only how much was borrowed, but how much in interest he has to pay. Because remember, you pay back what you borrow plus interest. So what did he borrow? He borrowed $45. That's called the principal. That's what we start with. So the interest is going to be $45 times R, which stands for the rate. And the rate, we say, is 2%. Times 2% times the time. In this case, we're dealing with months. And so he wants to do this for 6 months to pay it back. Remember, every month he gets charged a little bit. So for 6 months, so that's going to be 45 times 2% is the same as 0.02. And then times it by 6. That'll be our interest. But that's not how much he pays back, right? That's just the interest. That's the extra he's got to pay. So the total is going to be $45 plus the interest. So that'll give us our final answer right there. $45 plus interest over 6 months. Okay, finish that up. Use your calculator to check. You ready? Let's go on. 26. Michaela holds her state high school record for 500-meter freestyle swimming event. Okay, she can swim the event in 4 minutes 50 seconds. At this rate, how far will she swim in 10 minutes? All right, so there's 2 things being compared, distance and time. The distance in this case and time usually goes on the bottom. So we've got distance and time. That makes sense. You could do miles per hour, meters per second, etc. That sounds right. So the distance would be, in this case, she can go 500 meters. Oops, unicorn. And then on the bottom, she did that 500 meters in 4 minutes plus 50 seconds. Now, 4 minutes and 50 seconds, how are we going to measure this? We're going to do it in just minutes? If we do it in minutes, then what do we do about the 50 seconds? We can't just say plus 50 because that would be plus 50 minutes. So what is a second in relation to a minute? Well, we know there's 60 seconds in a minute, so really 50 seconds is 50 60ths of a minute. It's 10 seconds away from being a minute. So 4 plus 50/60ths. Okay, so 4 and 50/60ths, let's think about that. That's the same as 4 plus 50 over 60. 50 over 60 we can reduce to 4 plus 5 over 6. And that's the same as 4 and 5/6. Okay, so really this is the same as 500 over 4 and 5/6. Okay, and now it wants to know how far can you go in 10 minutes. So we'll put the minutes on the bottom because we're having time on the bottom in the denominator, and then the distance, we don't know. So let's think. How do we get 4 and 5/6 to equal 10? What about x? How do we deal with that? Okay, so there's lots of different ways we can do this. One way to do this would be to change this to x and make it a proportion. And now we can just cross multiply to get the answer. So this is 4 and 5/6 x equals 500 times 10. Okay, so that will be 4 and 5/6 equals 5,000. Oops, times x. And to get x times a number, that means to get x by itself, we'd work backwards and say, well, that's the same as 5,000 divided by 4 and 5/6. Okay, so go ahead and divide 5,000 by 4 and 5/6. Remember, when we're dividing fractions, it really are mixed numbers. It really helps to put them into a fraction greater than 1. So 6 times 4 is 24, plus 5 is 29 over 6. So that's the same as 5,000 times 6 over 29. Okay, so that's as far as I'm going to take you. Go ahead and simplify the rest. Check your answer. Make sure it makes sense. It should be a number more than 500 meters. And since this is about 5, it should be almost twice as much. She used almost twice as much time, so the answer should be around 1,000. So check your answer. Make sure that makes sense. Okay, let's pause if you need more time. Otherwise, let's move on. 27. Mrs. Chen has 2 brothers. Mark is 7 years older than Mrs. Chen, and Eric is 11 years younger than Mrs. Chen. The sum of all 3 of their ages is 149. Use the 5D process to determine the age of Mrs. Chen. Okay, let's draw this out. Mrs. Chen, do we know? We don't know what she is, so let's just use x. Mark is 7 years older than Mrs. Chen, so that would be x plus 7, because he's 7 years older. And then Eric is 11 years younger than Mrs. Chen. So what we put for that one? Well, Mrs. Chen is x, so we'll do x. And he's younger, so it's minus 11. And we know the total, or the sum of all their ages, is going to be 149 years. Okay, so we can use the 5D process, or you could make this an equation. It's up to you. For Mrs. Chen, we'll pick a number. We've got x. We know x plus 7, and then x minus 11. So we'll pick an age that makes sense. We know it's pretty high, 150. It's almost 150. Divided it by 3, it'd be about 50 years old. So if they're all the same age, but let's just pick somewhere around 30 or 50. So let's do 40. Say Mrs. Chen is 40. That means Mark would be 47, and her younger brother would be 29. What's 40 minus 11? Be 30, and then minus 1, yeah, 29. Okay, so go ahead and add all those numbers up. What's the sum? Is it too high, too low, or just right? If it's too low, then you'll pick something higher than 40. If it's too high, then you'll pick something lower than 40. Go ahead and figure what that is right now. Pause to figure that out, and then make sure you write it in a complete sentence. How do you know how old Mrs. Chen is? And explain how you got your answer. Okay? All right. Let's move on. Whoops. This is supposed to be 27. I can't believe I missed that. All right, 28. For each equation below, solve for x. Show the process used to check your answer. All right, so here's our answer. We've got a number, 2.5 equals x minus 1 1/4. We can't simplify anything on the left. There's nothing on the right. Those are not common or like terms. So we need to get rid of this part, 1 1/4. So let's add 1 1/4 so that this will combine to make 0. So then that means over here, I'll give it some more room. This will be 2.5 plus 1 1/4 equals x. All right, so x is going to be, I'll convert these for you. 2.5 is the same as 5/2. And 1 1/4 is the same as 4/4 plus 1/4, which is 5/4. Go ahead and find a common denominator. You can use 4. Use a giant 1, multiply it across, add those together, and then you'll get x. Once you have x, go ahead and substitute it back into the equation right here, and you should get both sides equaling 2 1/2. All right, make sure you got the same though. You got to be able to check your work and show it. So that's how you do it over there. Okay, let's move on. B, 5x equals 2x plus 12. We've got x on the left, x on the right. That means that we can use our second legal move, which is to take out pairs that are the same on each side, or twins as we call it. So the twins, there's at least 2 sets of twins on the left and on the right, so we'll take out 2 twins. So that leaves us with 3x equals 12. Okay, go ahead and do the second step there to figure out what x is, and then substitute it right in here for these two to find that part there. And then once you've checked your work, let's go on to the next one. And for C, last one. For each equation below, solve for x. Show the process used to check your answer. So x minus 14.6 equals 8.02. X on the left side can't be simplified, and on the right there's nothing to simplify. There are 1 tiles over here, so we've got 14.6 on the left and 8.202 on the right. We can take those away by, 14.6. Combine those together. So x is going to equal the sum of 8.02 and 14.6. Don't forget to line up the decimal. I didn't do that here, but you can do that on your paper. Once you get your answer, substitute it back in, and your answer should be the same as 8.02 on the right. You should get the same on the left. Double check your work, show how to do that, and when you're done, go ahead and unpause. All right, you're all done. Great job. Keep working hard. If you need anything, let me know. I'm here to help. I just want to tell you now.
Congratulations on completing your homework assignment. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math to get updates on future videos. Thanks for watching.
MrConnally.com